Assalamualaikum warahmatullahi wabarakatuh. Today we are going to presentate about the inverted pendulum. The inverted pendulum is a well-known problem in dynamics and control theory that can be used to understand and construct control systems. It is made up of a rigid rod or a pendulum pivoted at one end and free to revolve at a fixed axis, with the center of mass above the pivot point, making it inherently unstable. Because of their complex and nonlinear dynamics, inverted pendulums are the subject of extensive research. They pose a serious problem since they need constant modifications to offset the effects of gravity in order to maintain balance.
Okay, so what is an inverted pendulum? So, inverted pendulum is a dynamic system where a pendulum is balanced on its pivot point with its center of mass above the pivot. This configuration is inherently unstable, meaning that without continuous adjustment, the pendulum will fall over. So one common method to achieve stability is using a proportional, integral, and derivative controller, or the PID controller. So the PID controller adjusts the force applied to the pendulum's base based on three factors: the current error, or proportional, the accumulated past error, or integral, and the rate of change of the error, or derivative. The proportional component addresses the immediate deviation, the integral component corrects long-term drift, and the derivative component smooths out rapid changes, preventing oscillation. Proper tuning of the PID parameters is essential to ensure quick and stable responses.
Okay, so here we made a code using Python. So this code simulates and animates a pendulum attached to a cart, demonstrating a swing up control and stabilization. Using energy-based control, the pendulum is swung to its upright position by manipulating its kinetic and potential energy. Once near upright, a state controller stabilizes the pendulum using PD or a proportional derivative. Proportional derivative. And here you can see the PD. The KP is the proportional and the D is the derivative. So it's a feedback loop. And the system dynamics are modeled by ordinary differential equation, or ODEs, which are solved numerically using this script SciPy integrate. And the animation created by the matplotlib animations. And to visualize the cart movement, the pendulum oscillation, and the display the time and energy. The simulation showcase how the two control strategies work together to achieve vertical stability.
So, what is an inverted pendulum? An inverted pendulum is a pendulum with a center of mass above its pivot point, making it very unstable and prone to falling over. In this final project, we managed to simulate the working principle of an inverted pendulum using Python. We simulate and animated a pendulum attached to a cart, demonstrating swing up control and stabilization. By utilizing SciPy library to solve the inverted pendulum numerically, and using matplotlib animation to animate the working principle of the inverted pendulum, we managed to finish this project by simulating the inverted pendulum and showing its actual application. Thank you.